Welcome friends. Today we shall continue our discussion on differentiation. In the previous lectures we derived the standard results for differentiation. We obtained expression for differentiation for various functions. So let me show you what we have done up to now. So we got standard differentiation results for various functions. If you look at here, these are basically the standard differentiation of functions. We have taken various functions. If you look at this table, we use the basic definition of differentiation and we obtain the expression for the differentiation of standard functions. For instance, if you see here, this is an algebraic function x raised to n and the differentiation of algebraic function is nx n minus 1. Similarly, we also obtain the expression for differentiation of constant trigonometric functions. Derivative of sine is cos x is minus sine x, secant x. We also found the derivatives of various other functions like exponential functions, a raised to x, e raised to x, logarithmic function, inverse functions in our previous discussion. So let me remind you, this table is very important. We must understand how to use this table. So we need to memorize these expressions. For some time you can keep this table in front of you. You can refer this table and try to apply these results to the problem. But as you do it continuously, you may remember these formulas and you can easily apply them during the course of solving problem. So let's continue from here and try to understand how to find differentiation of a given expression. So before starting with the actual problem solving, let me give you some very important results, and these are called as rules of differentiation. There are few rules of differentiation which you must remember before going to solve actual problem based on differentiation. Okay. So first rule is called as addition or subtraction rule. Addition or subtraction of function. For instance, you have a function y equals, so y is basically f of x. We already used similar notation earlier. So y equals f of x equals, we have number of functions, let us say. So we have, let's say, first function u is a function of x. Then we have plus or minus second function v, plus or minus third function w. So y is basically summation or sum or difference of various functions. Okay, u, v, w. Here u, v, w all are the functions of x. So where u, v and w are functions of x, like this. If I differentiate this, so differentiation or derivative is given by, so dy over dx, or if you write in this form, f dash of x, that is the first derivative of x, function f of x, will be, you will differentiate u, that's fine. Then this sign plus minus would remain as it is. Then you will differentiate v, then sign would remain as it is, and differentiate w also. So this is basically a kind of distributive property. So differentiation is distributed over all the functions u, v, w. So it is also called as distributive property, but we need not to remember anything like that. Simply it is, if it is plus or minus between number of functions, you simply distribute the differentiation to each and every function. That is the first one, addition or subtraction. Now let me give you another rule which is called as multiplication rule. This was addition or subtraction rule. Now we have multiplication rule. So what is multiplication rule basically? So now let me write down. We have y equals f of x, function of x. Now we have number of functions multiplied together. Let me take two functions. One function is u and the second function is v. So as usual, u and v are the functions of u and v are functions of x. So this is here how you get a differentiation is very interesting. So differentiation of y, which is nothing but derivatives of f of x, is now what you do like this. This is called as product rule. So u or multiplication rule dv by dx. So you first differentiate one function, then second time you differentiate other function. So one by one you differentiate each function, keeping other function without any differentiation. Okay. Now what? So if you have another function note, suppose you have, instead of 2 you have 3 functions, then also same rule would be applicable. If you have y equals u times v times w, so here differentiation of y same. You have to take one by one. So you take u and v as it is. You differentiate w first. Anything you can do first, no issue. Then you keep u and w together. Then differentiate v, and then you keep v and w as it is, and you differentiate u. So you have to do one by one differentiation of in each individual function. So this is called as product rule or multiplication rule of differentiation. Okay, I'm not going to give you proof of this, but you can directly take it. We may discuss later if it is required, but right now it is not at all required. You simply remember the rules of differentiation. Now, third rule is called as division rule, which is interesting, or quotient rule it is also called as. If we have y, which is the function of x, is the quotient or ratio of two functions u and v, then what is the differentiation of y? So differentiation of y with respect to x or f dash of x is something like this. So we will have a ratio in which the denominator would be written as v square, and here we write v first and we write differentiation of u, then we write u, and then we write differentiation of v. Okay, so v differentiation of u, that is v is the denominator derivative of numerator minus numerator times derivative of denominator, whole divided by the denominator v the whole square. Okay, you should always remember v is not equal to 0. So these are three rules which are called as simple rules of differentiation. By using these simple rules of differentiation, now I'll show you some examples that how to apply the standard differentiation results like for various functions along with rules of differentiation. So let me give you some example in order to understand the process involved in the differentiation. So my question is, find the derivatives of following functions with respect to x. This is the question. Let me take first function a. My first function is x raised to 5. I want to find the derivative of this function with respect to x. Okay, let me tell you how to go for solution. I will call function let the function y equal to x raised to 5. Now I want to find differentiation of x raised to 5. So I have named x raised to 5 as a function y. Now I will differentiate this. So differentiating the given function y with respect to x. This is the procedure we are following. So whenever we differentiate, we are going to use differentiating with respect to x. So the differentiating with respect to x signifies by this particular notation d by dx. This particular term signifies what? Differentiating. If I introduce this particular term d by dx, it signifies differentiating with respect to x. Okay, if I write d by dt, it will be differentiating with respect to t. Okay, so the differentiating with respect to x will introduce d by dx term in both sides. So I will be getting d by dx of y in the left hand side, while d by dx of x raised to 5 in the right hand side, as you have seen. Now the left hand side is very simple. You can simply write down, that is d of y by dx. That's okay. That is derivative of y with respect to x. We will read it like derivatives of y with respect to x. In the right hand side, we have derivatives of, so d by dx, as you know, it means derivatives of x raised to 5. Now the question is how to find derivatives of x raised to 5. So in order to find derivative of x raised to 5, I have to look for a standard result I have got for similar functions. So if you look at our standard results, I have got x raised to n, and the derivative of x raised to n is nx n minus 1. So let me write down that here for your understanding. So we have a standard result. The derivatives of x raised to n is n times x raised to n minus 1, right? So this already we have derived in the previous session. The derivative of any function in the form of x raised to n is nx raised to n minus 1. So if you look at here, this standard result, that is x raised to n, standard function x raised to n is similar to x raised to 5. Only difference is that instead of n, we have 5 over here. So since derivative of x raised to n is nx n minus 1, derivative of x raised to 5 would be, instead of n, I will write 5, so it is 5, then x raised to n minus 1, that is again 5 will be n minus 1. So you will be getting derivative of y with respect to x as 5 x raised to 4. Okay, so this is the derivative of x raised to 5. Fine. Let me, so kindly remember, this is the algebraic function we have done earlier. Now let me take another example also. If I take second function, just to clear your idea, let me say I have x raised to minus 3. This is the second question. We wanted to find out derivative of x raised to minus 3. So how to find derivative of x raised to minus 3? So if you look at it carefully, x raised to minus 3 is similar to what? X raised to n. If I differentiate x raised to n, I should get, as per the result, nx n minus 1. So similarly, if I differentiate x raised to minus 3, so if I differentiate x raised to minus 3, I should get in similar format. Okay, so I'm just keeping it here for your observation. Okay, and you please try to do it along with me and see whether you are comfortable or not. So procedure is again same. I'm going to assume it as, we'll write solution and then we write let the given function is y, and then we differentiate with respect to x. This procedure you have to follow, differentiating with respect to x, and then whenever you differentiate you are going to introduce dy dx, which means the differentiation with respect to x on both sides. Okay, this is nothing but dy over dx, and this is, I'm going to use this result. I'll be using this result, friends. Here if I use this result, it will be n is minus 3, x raised to minus 3, that is n minus 1. This will turn out to be minus 3 x raised to minus 4. Okay. So this way you can find out differentiation of x raised to minus 3. Let me take one more example. See, I have a function x raised to minus 7 plus 5x raised to 2 minus 3x. Now if you look at this, here we have three different functions. Okay, so you have to remember our rules of differentiation, what we discussed earlier. So we discussed rules of differentiation. If we get number of functions having additions or subtraction between them, we simply distribute the differentiation among them. Okay, what we will do, we will distribute the differentiation among each individual functions. Okay, that's what you can see here. So here we have three different functions, which is, you can call this function as u, this function as v, and this function is w, and there is plus and minus between them. So if you want to find differentiation of them individually, you will differentiate each one. So kindly remember this. I'm going to solve it. The procedure is again same. We will say let y equals x raised to minus 7 plus 5 x square minus 3x, and then our same procedure differentiating with respect to. So if you differentiate with respect to x, as usual, d by dx would be introduced because we are differentiating with respect to x to each and every term, right? I hope it is clear to all of you. D by dx minus 7, symbol between them is plus, so plus would be as it is, d by dx 5 x square minus d by dx 3x. So if you look at this, this will become dy over dx. Now I need to tell you a very important thing here. If you observe, here we have 5. So 5 and 3 are basically constants. This is also a constant and this is also a constant. So if we have these constant terms, we can always take constant terms out of differentiation. Please note that differentiation of a constant time function of x, if we have like this, so the constant would come outside, and then differentiation would be only applicable to the function of x. Like this is very important point to remember here. So please remember, this note is extremely important, because whenever you differentiate a functions multiplied by a constant, so the constant can be simply taken out of differentiation and you can apply differentiation to the function of x. So the same method I am going to use here. So here there is no issue, it will be only we have variable terms, x raised to minus 7, so it is as it is. But here I will take 5 outside because 5 is constant. 5 d by dx of x square, and here 3 is constant, I can take 3 outside, 3 d by dx of x. Now we shall use our result. Result is what now? That is x raised to n. Derivative of x raised to n is nx n minus 1. Okay, we will use result. The derivatives of x raised to n is nx n minus 1. So this result I am going to use here. If I use this result, what I shall get? Let's see. So minus 7 x raised to minus 7 minus 1. Here n is minus 7. 5 constant as it is. I have applied x raised to n for x square. So 2 into x raised to 2 minus 3 as it is. For derivative of x. So x power 1 we have. So 1 times x raised to 1 minus 1. So if you look at this whole thing, see x has power 1, degree 1. That degree 1 I have taken here. and then degree becomes n minus 1 is 1 minus 1. So you will see here minus 7 times x raised to minus 8. 5 into 2 is 10. 10 times x raised to 1. And here 3 x raised to 0. So x raised to 0 is what? Anything raised to 0 is 1. Kindly remember, anything raised to 0 is 1. Okay. So this will be further simplified. Minus 7 x raised to minus 8 plus 10x minus 3 into 1, that is 3. So your derivative of the function is dy by dx is minus 7 x raised to minus 8 plus 10x minus 3. Now one very important result we have got here, just to remind you. So we have got the derivative of x is 1. You can see here. If you look at this derivative of x, we got here 1. So we can note one more thing here. Just keep a note. The derivative of x is 1. Okay. This information you can also update that here. So just as a note, I can write down here few notes so that you can directly use them. So note is derivative of x function, only x if it is going to be 1. So derivative of x will be 1. Kindly remember the standard table. Okay. So this was the third question. So we have found derivative of x raised to minus 7 plus 5x square plus minus 3x as minus 7 x raised to minus 8 plus 10x minus 3. So we have third question. Now suppose we have sin x minus 2 tan x plus 3 cos x. Now we have to find derivative of this particular function, that is sin x minus 2 tan x plus 3 cos x. So we will again follow the same procedure. We will say let y equals sin x minus 2 tan x plus 3 cos x. And again the same differentiating with respect to x. So when we differentiate with respect to x, we have to introduce d by dx to each and every term. D by dx y equals derivatives of sin x. You can look, if you look at here, this 2 is constant term, so we can take constant term outside. You learn already. So 2 d by dx of tan x. You only apply differentiation to the variable term. Here also we have 3 as a constant term, so I can take 3 outside. And we apply derivatives to only variable term, that is cos of x. So what is derivative of sin of x? You can look at here, we have already derived the result. Derivative of sin of x is cosine of x. What is derivative of tan of x? So derivative of tangent of x already we have secant square x. And derivative of cosine of x, if you look at in table, derivative of cosine of x is minus sine of x. Okay, so I'm going to use these three standard results over here. This will become dy over dx. Now derivative of sin x is cosine of x. 2 is constant as it is. Derivative of tangent of x is secant square x. 3 constant as it is. And cosine of x is derivative of cosine of x is minus sine of x. So therefore derivatives you are going to get as cosine of x minus 2 secant square x. Now this is plus and this minus, so 3 sine. This way you can easily find out the derivative of the function. So we have another problem where we have 3 e raised to x minus 5 sine inverse of x plus 9 x raised to 8 plus 50. So you can look at this. So now we have different functions, we can say. We have one function e raised to x, another sine inverse of x, then x raised to 8, and the last one is a constant function. Okay. So this is an exponential function. This is an exponential function. E raised to x is an exponential function. Sine inverse is the inverse function. X raised to 8 algebraic function, and 15 is a constant term. Okay. So we will follow the same procedure. So let y equals 3 e raised to x minus 5 sine inverse of x minus 9 x raised to 8 plus 15, and we'll differentiate with respect to x. So when we differentiate with respect to x, what is going to happen? The differentiation is applied to each and every term. Okay, but remember 3 is a constant term. We have constant and variable term, so constant would come outside. 5 is a constant term, 9 is a constant term, while 15 is the only term remaining here. So we should not take 15 outside because it is an individual term, right? When constant and variable comes together, we can take constant term out of the differentiation. So let's see how we write it. So it is d by dx, that is derivatives of y. Here 3 is constant, so 3 derivatives of e raised to x minus 5 derivatives of sine inverse of x minus 9 again constant outside derivatives of x raised to 8. Now here if you look at, we have only single term, that is 15 constant. Okay, as a constant. So we cannot take 15 outside because it's a individual term. There is no variable term available. So we will do differentiation of that constant. So let's see what you get from here. So this is going to be dy over dx. Now 3 as it is. Now derivative of e raised to x, exponential function. So let us refer the table. Differentiation of e raised to x is e raised to x itself. So I'll write down e raised to x as it is. No changes. Minus 5 constant. Now differentiation of sine inverse of. So we have the standard result for it. You can see here. So derivative of sine inverse of x is 1 over 1 minus x square. You can put that value also here. So we have x raised to 8, which is similar to x raised to n. So derivative of x raised to n is, you can see the table, derivative of x raised to n is nx n minus 1 and x raised to n minus 1. You can apply here. N is 8 times x raised to 8 minus 1. And now the last term, differentiation or derivative of 15. So the 15 is basically a constant term. There is no variable term here. It is very important. Remember, the 15 is a constant term. We don't have any variable here. It is a constant term. So for a constant term, the derivative of constant term you can see in table. So derivative of constant is 0. Any constant stands for a function independent of x. A function in which there is no x term. So if you look at here, the 15 is a function where there is no x term involved. Okay. So when there is no x term involved, the differentiation of it would be 0. So that is equal to 0, right? So now you simplify this. So you will get dy by dx, that is derivative of the function, as 3 times e raised to x minus 5 over 1 minus x square. 9 times 8, that is 72, x raised to 7, 8 minus 1, 7. So this is the derivative of the given function. Okay. We'll take some more questions. That is f. So we have 5 log of x to the base 3 minus 15 divided by x raised to 5 minus sine inverse of x plus 2 tan inverse of x times plus 170. Now we want to get differentiation or derivative of this function. Okay. So if you look at this function, let me follow the same procedure. So let y equals 5 times log x to the base 3 minus 15 x raised to 5 sine inverse of x 2 tan inverse of x plus 172. Please remember, you have to simplify this function in order to differentiate it. So before differentiating, let me simplify each function. Like if you look at this function, which is not in the pure logarithmic form, we have base 3. So here, for as far as our standard results are concerned, we have pure log to the base e. Okay. So we know differentiation of log of x to the base e or log of x. But here we have log of x to the base 3. So we need to simplify this first. So if I simplify this, we know that log of a to the base b is log a over log b, right? So by that rule, you can write down, therefore log of x to the base 3 would be log x by log 3. So this is one simplification we could do. So you have seen that we can simplify the given function in order to get the standard form. If you look at 15 by x raised to 5 also, the next one also, this, if you look at 15 divided by x raised to 5, this also we need to simplify. So the 15 divided by x raised to 5 can be simply written as 15 times x raised to minus 5. Okay. So we are able to simplify the functions which are not available in the standard form. Okay. So now why I have done this particular simplification, because we want x raised to n sort of thing. Okay. So now let's do it. So your y would be 5 times log x by log 3 minus 15 times x raised to minus 5 minus sine inverse of x plus 2 tan inverse of x plus 170. Now it is in the somewhat standard form. Differentiate to x. If we differentiate with respect to x, we know that we will introduce d by dx term to each and every term of the function. Okay, so it is, now if you look at here, 5 and log 3 are constant. This 5 and this denominator log 3 are constant, so I can take them out of differentiation and will only apply differentiation for log of x. 15 is constant again, so differentiation of x raised to minus 5 minus differentiation of sine inverse of x. 2 is constant, differentiation of tan inverse of x, and 172 is a constant term. Remember, there is no variable term involved, so I will directly apply differentiation to it. So it is plus differentiation of 170. So let's see what we can get here. Therefore, this becomes dy over dx. Now 5 divided by log 3 are constant, as it is, no change. Now differentiation of log x. So let's see the table. So differentiation of log x is 1 over x. So let's write down minus 15. Now x raised to minus 5 is similar to x raised to n. So derivative of x raised to n is nx raised to n minus 1. So n is minus 5 times x raised to minus 5 minus 1 minus or derivative of sine inverse of x. So let's see what is derivative of sine inverse x in the table. So the derivative of sine inverse of x is 1 divided by under root of 1 minus x square. 1 divided by under root of 1 minus x plus, now we have derivative 2 as constant, so derivative of tan inverse of x would be, let's see the table again. What is the derivative of tan inverse of x? 1 divided by 1 plus x square. We write down that also. And now the last term is derivative of 172. So 172 is a constant. So by this time you must be remembering the derivative of constant is 0. So now let me simplify this whole. So you will be getting, therefore dy by dx would be 5x log 3, 15 5s are 75, minus multiplied by minus is plus 75 times x raised to minus 6 minus 1 square root of 1 minus x square, and the last term is 2 divided by 1 plus x square. So you can see that we are able to find out derivatives of function. So if you look at here, we have not used any multiplication of function or division of function. We have only done simple addition or subtraction of function. So that is, if you look at from question 1 onwards, first onwards, we have only taken the addition or subtraction of the functions, but we have not used any question based on division or multiplication. So now I think we should take some questions based on division as well as some questions based on multiplication in order to understand. So let's see. So we would like to do problems based on multiplication and division of functions. So my first question is 1 plus sin x times x square plus cos x. I want to find derivative of this function with respect to x. Before going for the problem, let me remind you the multiplication rule or product rule. Okay. So what product rule says? That is, derivatives of u times v is u times derivatives of v plus v times derivatives of, okay. So if you have two functions, they are multiplied, the derivative of their product is given by first derivative of second function plus second derivative of first function. So if you follow this particular rule, you will be able to easily find out derivatives of product of two functions. So let me show you the procedure, how to solve this. Again, the same method we are going to adopt. Writing method is same. Let y equals 1 plus sin x times x square plus cos x. If you look at here, this whole function is u and this whole function is v, okay, and they are multiplied together. So we have y equals u into v, u into v. So let's do it. Differentiating with respect to x. Same procedure, I am going to introduce d by dx of y, and now u derivative of v plus v derivative of u. So u is here 1 plus sin x derivative of v, that is x square plus cos x, then plus v times derivative of u. So v is, without any derivatives, you write x square cos of x, and then that times derivative of u. Derivative of u is, what is u? 1 plus sin x. Alright, so we can continue here. 1 plus sin x, it is as it is, there is no differentiation for it. We should simply write down 1 plus sin. Now here if you look at differentiation of x square and cos x. So as we did earlier, there are two functions multiplied together, so differentiation would be applied for x square as well as cos x. If you look at here, x square plus cos x, now derivative of 1 and derivative of sin x, okay, we'll apply derivatives or differentiation for 1, we'll also apply derivatives. So now what you will get is 1 plus sin x. Now if you look at here, it is x square. So x square is similar to x raised to n, and by this time you must be remembering the derivative of x raised to n is n times x raised to n minus 1. So this would be n is 2, so 2 into x raised to 2 minus 1 plus derivative of cos of x. So let me show you the table. The derivative of cos of x is only minus sin of x. Please apply proper brackets so that there is no chance of error. X square plus cos x, nothing to it, as it is. Now derivative of 1. So 1, if you look at, 1 is a constant term. There is no variable involved in this. So 1 is a constant term. The derivative of constant is 0. We have already understood this. So it will be 0. The derivative of sin x, you can see the table again. Sin x derivative is cos x. So we can put cos x there. Alright? Alright. So let me simplify it. So 1 plus sin x, 2 times x raised to 1. So it is 2x minus sin x. Here it is x square plus cos x times only cos x. So this is your final answer. You can simplify this, but at this level it is not required to be simplified because you don't get anything useful out of simplification here. So you can simply stop at this particular point. This is your derivative of this particular function. Now let me take one more example. We have, let's say, e raised to x plus 2 tan inverse of x times x cube plus 4. We need to find out derivative of this function. So again, there are two functions multiplied together. We can use u into v, that is product rule. So let's continue. Y equals, so I'm just writing the whole thing again. Let y equals to this and then differentiating with respect to x. So as you know that here, if you see, this is u multiplied by this is v, u and v. So we can use the rule y equals to u into v. So you know that already, you've done previous thing. The rule is here, product rule. So let me apply that here. So you shall be getting d by dx of y and then u derivative of v plus v derivative of u. So I'll write down same as e raised to x to tan inverse of x into derivative of v. So d by dx derivative of v, that is x cube plus 4 plus v derivative of u. So v is x cube plus 4 derivatives of u. What is u? U is e raised to x plus 2 tan inverse of. So again the same rule. Here there is no differentiation involved, so this is going to be dy over dx, and this is e raised to x. So derivative of x cube plus 4. So let me again follow the procedure. So derivatives of x cube, derivatives of 4. Here x cube plus 4 as it is. You will have derivatives of e raised to x. Now 2 is constant, so constant would not be applicable. 2 out, it will come outside. 2 times derivatives of tan inverse of x. Okay, if I go ahead, so you have e raised to x to tan inverse of x as it is, no change. Now we know that the derivative of x raised to n is nx n minus 1, so it is 3 times x raised to 3 minus 1 plus, now 4 is a constant term. Again remember it, the 4 is, there is no x term involved in the 4. So it is a constant term, so derivative of constant term is 0, so it is going to be 0. You can see the table with you. I hope you have made a table. You can see the table along with me if you want. Now it is x cube plus 4. Now derivative of e raised to x, again if you see the table, sometimes I will show you the table also. E raised to x, derivative of e raised to x is e raised to x itself. It is going to be e raised to x itself, no changes, plus now 2 is constant, no worries. Now derivative of tan inverse of x, let me show you again the table. Derivative of tan inverse of x is 1 over 1 plus x square. It is 1 over 1, right? So this will be as it is, there is no change further. This will be 3 times x square plus x cube plus 4, and here you will have e raised to x plus 2 divided by 1 plus x. Now this is your derivatives of the function. Now we can multiply these two terms together, but there is no valuable outcome I am going to get from here. So there is no need to unnecessarily simplify it. Okay. So this is your final answer. But I think here we'll stop in this particular lecture. So you please go through this whole exercise we have done today. In the next subsequent lecture, we will take the division of two functions. How to find the differentiation of division of two functions. So thank you very much.